Section 2 deals with order of operations, evaluating numerical and algebraic expressions, the things we've been working with so far, using order of operations. And we need to know what evaluate means. Evaluate is a direction that you're going to be given a lot. What does evaluate mean? It's kind of like solve, except we don't have an equal sign. Yes? Yeah, you might have to plug in a number. You might have to simplify things down. Basically, that's what evaluate means, okay? If you have an equal sign, you won't see the word evaluate. You'll see the word solve. Solve means solve. There's an equal sign. Evaluate means you have an expression, and you're just simplifying it down. So that's what evaluate means. Now we're going to also explain the tricks to GEMS. You probably have never heard of GEMS because probably you learned something else, some other acronym for order of operations. Yeah, you probably learned PEMDAS if you didn't learn GEMS, okay? We've switched to GEMS, and the reason that we've done that is because the M and the S make it a little bit more obvious that what the M and the S stand for happen at the exact same time. PEMDAS people screw up the M and the D and the A and the S because they think that they happen separately, but they don't, okay? So this little acronym right here makes it a little bit easier. If you don't know what I'm talking about with PEMDAS, don't even Google it. Just push it out of your mind, all right? It's order of operations. So the order of operations, our little vocabulary word here, order of operations is the order in which the world solves a problem. We had to come up with an order of operations because the people in the United States may have been trying to solve the same exact problem differently than the people in France. And those people may have been solving it a different way compared to the people in Russia. So we had to come up with a universal way to solve these mathematical problems, okay? And that universal way is known as the order of operations. You have to solve the problem this way. If you don't, you may get the wrong answer. In fact, you probably will get the wrong answer. So we have 4 letters in GEMS, G-E-M-S. We need to talk about what each of those letters stands for. Each of those letters in this word GEMS tells me what comes first or what comes next. Okay, what does G stand for? Grouping symbols, that's right. Okay, parentheses are grouping symbols. Okay, so I'm going to put little parentheses in here. But in algebra, we use other symbols besides parentheses. Do we know any of these other symbols? Yeah, we use what we call brackets, and that's these guys. And we can use parentheses and brackets in any combination to show more grouping symbols. There's actually another grouping symbol that we use. This is called a brace. You'll hear me say the phrase squiggly bracket. When I say squiggly bracket, I'm talking about this. Typically, we don't use the squiggly bracket as a grouping symbol in these types of problems. But there is one more that we do use, and it's not one that you typically think about. Anybody know it? This. What is that? It's a little line. Happens to be a horizontal line. What do we use horizontal lines for? Division problems, yeah. A division bar is also a grouping symbol. What it's done is it's grouped the numerator and the denominator. Okay, so we have to think about that one also. Those are grouping symbols. Okay, what is E? Exponents. We talked a little bit about exponents last time. They're pretty straightforward. If you have an exponent, it's in, what was that word we said? We have our regular writing, and then above the line it's called superscript. Good. So if you see something in superscript, like x to the fifth power, that's your exponent. All right. Exponents come after grouping symbols. So we take care of these first, and then we go on to that. What is M? Thank you. Multiplication and division. Okay, so multiplication and division. The important thing with multiplication and division, I'm over here now. Remember, multiply and divide. What's important about multiplying and dividing for order of operations? Very good. They happen at the same time. And there's more, actually, that you have to know. Does anybody know it? From left to right, just like reading a book, okay? So, multiplying and dividing happens at the same time. If I see division on the left and multiplication on the right, the division happens first, and then the multiplication. It's from left to right. You have to follow that. And that's why multiplication and division is written together right here. All right, the last thing, the S. What is the S? Subtraction and addition. And there's also something we have to remember with addition and subtraction, or subtraction and addition. What do we have to remember there? They happen at the same time. Anything else?
Left to right.
From left to right, that's right. That is your order of operations. As you solve all of your problems, you must follow order of operations every time. Even if the problem does not look like this. We can have problems that have just numbers in them, and we see the multiplication and division, addition, subtraction, grouping symbols, exponents. We see all that in those problems. But as this course goes on, and through later math classes that you'll have to take here, you will have problems that you need to be careful to watch your order of operations on, because you can screw them up, okay? So even though these are kind of what we would call simple problems, you have to remember them from here on out. It's expected that you know them. So let's take a look at this problem here, 2 plus 3, and then we have that cross symbol, which we said means multiplication, and we also said that we will stop using it pretty soon, okay? So for now, we're seeing that X symbol there. It does not mean X. Right now it means multiplication. Very soon we will never see that symbol again in math. So enjoy it while it lasts. What happens first here? The multiplication. We have to follow gems. Do we see grouping symbols? No. Do we see exponents? No. Do we see multiplication or division? Yes. So we must do that first. When you multiply, what do you get? Yeah, the 3 times 5 here turns into 15. So I'm going to rewrite that entire line, and this is how I want you to do these problems. Rewrite the entire line, 2 plus, and then I multiplied 3 times 5, which is 15, so I'm going to write 2 plus 15. Okay, and then after you do that, and this seems painful on this one because it's so obvious what the answer is, hopefully, to everybody, but after you do one step, you go back and start over. Do I have any grouping symbols? Do I have any exponents? Do I have any multiplication or division? Do I have any addition or subtraction? Yes. So I do that from left to right. And we have 2 plus 15, which is 17. So the next line down, I'll write 17 and circle my answer. This is how you need to do these problems. Step by step, line by line, one thing at a time until you get to an answer. Okay? Some of these problems will make you use 5 or 6 lines. Use 5 or 6 lines. Be very careful as you go. All right? You have to do it this way. So let's try the next problem. What is the simplified form of the expression? How do we read that? Let's read that first. What does it say? 10 to the 7th power. Good. What does it mean? 10 times itself 7 times, right? So I have 10 times 10 times 10 times 10 times 10 times 10 times 10. Is that 7? Yeah. That's what that says. That's what exponents do for us. Exponents are a shorthand way of showing lots of the same multiplication happening. So what should I do? Multiply it out. Do I have any grouping symbols? Do I have any exponents now? No, I've written it all out, all right? Now, down the road, we're not going to write all this out when we have an exponent. We're just going to figure out what it is, okay? But for this example, we wrote it all out. So, the exponents are gone. Now what? Multiplication or division from left to right. Do we have any of that? Yeah, it's all multiplication. So, let's go. We have 10 times 10, which is 100. Now, I'm just going to show you how you would have to do this if you were doing it step by step, line by line. I'm going to write 100 times 10 times 10 times 10 times 10 times 10. Next, do I still have multiplication? And it goes from left to right. So that would be 100 times 10, which is 1,000. So now I have 1,000 times 10 times 10 times 10 times 10. And then I start over. Do I have any multiplication or division? Yes. 1,000 times 10 is 10,000. Now you guys can see this pattern, right? Do I need to go any farther than that? Do I need you to see every single step like this? Okay. So what we have here is 1,000 times 10, which is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is 1 million. 1 million times 10 is 10 million. So I need to write down 10 million, all right? 10, comma, that's my 10 million, and then I need 1, 2, 3, 4, 5, 6 zeros afterwards. That's 10 million. Put a circle around it, and we're done. Now you're not going to be able to skip steps on these order of operation problems like I just did. The only reason I did it is because we can figure out what 10 to the 7th power is without doing all of this. Type it into a calculator. 10, exponent, 7, enter. It'll give you 10 million. How about 0.2 to the 5th power? Let's talk about that. What does that mean? (0.2) times itself 5 times. Notice that there's parentheses there. Does that mean I have a grouping symbol? No, it doesn't. The grouping symbol is when I have things like 3 plus 5 and there's parentheses around that. This is just showing me that this whole thing right here is just a number. It's a number raised to the 5th power. That's why the grouping symbol is there. It's there to visually help you see that that's just a number, okay? So we have 0.2 to the 5th power. Just like over here with 10 to the 7th, what really this says is 0.2 times itself 5 times. And if we wanted to find out what this is and we didn't have a calculator, we would have to do what? Just start multiplying it out. So we have 0.2 times 0.2, which 0.04 times 0.2 times 0.2 times 0.2. And then we continue. Hopefully you have a calculator in front of you though, because 0.2 to the 5th power is going to give me a pretty small fraction, a pretty small decimal, like 0.000 something, okay? What is it? 0. I don't know, we're guessing here. The benefits of having a calculator sitting right in front of you most days. Then you can just do this when I'm asking. So I'm going to enter in 0.2 and raise it to the 5th power and press enter, and I get 0.00032. 0.00032, done. Way faster than trying to do that by hand, okay? Now some of this stuff, yeah, we're going to use a calculator for it. Do I expect you to know off the top of your head what 0.2 to the 5th power is? No, of course not, okay? That's a calculator type problem. Do I expect you to know what 8 times 6 is off the top of your head? Yeah, that's something you should know, okay? That's just going to make you faster in life when you're trying to come up with some of this stuff. So, this is good enough. What does 3 to the 4th power mean? 3 times itself 4 times. 3 times 3 times 3 times 3. That is an easier problem that we can do without a calculator. What do we get? 81, nice. because 3 times 3 is 9, times 3 times 3. 9 times 3 is 27, times 3, and 27 times 3 is 81. All right, that is something we can do by hand. Or, we haven't talked about the properties of multiplication yet. You could do 3 times 3, which is 9, and over here 3 times 3, which is 9, and then 9 times 9 is 81. A little bit easier multiplication there. We'll get to that, okay? For now, this is how you have to do it. We're following gems from left to right. 2/3 to the third power. How do we do that? Yes, that is a rule of exponents that we could do, but I want to write this out. So this actually says what? 2/3 times 2/3 times 2/3. Notice I went to the dot instead of the parentheses. Is that okay with everybody? Okay, just makes it a little bit faster for me. How do I multiply something like this? What? How do you multiply fractions? Straight across, good. 2 times 2 is, times 2 is, and then 3 times 3 is, 9 times 3 is, so we have 8/27. And then when we have fractions, we always have to do what? Simplify, meaning reduce. We always reduce fractions. Does this reduce? What are the factors of 8? Is this even? No. Does this reduce? So 8/27 is the answer. Finally, what does that say? Somebody please who has not contributed yet so far. How do you read that? What do you got? The last problem. How do you say that? Like if I asked you to read it out loud, which I am. 0.5 to the third power. Good. And what does it mean? 0.5 times itself 3 times. That is math that we can do by hand. 0.5 times 0.5 times 0.5. Basically, that says 1/2 times 1/2 times 1/2. What is 0.5 times 0.5? No. 1.5 plus 0.5 is 1. What? Nope. What's 5 times 5? 25. So 0.5 times 0.5 is 0.25. So we have 0.25 times 0.5. So what's 0.25 times 0.5? What's that? 0.125. That's right. 0.125. Incidentally, if I had written this as 1/2 times 1/2 times 1/2, which do you agree? 0.5 is 1/2. How do I multiply fractions? Straight across. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. If I take 1 and divide it by 8, guess what I get? 0.125. So this is the correct answer, and I just want to point that out to you to show you that you can work with decimals, you can work with fractions. You can. You just got to kind of work with them, and then you get to the point where you're familiar enough with them that these numbers start to make sense to you. So now we're getting into the actual meat of this section. Using GEMS, order of operations, to simplify problems down, to evaluate problems. Okay? So let's take a look at this first one. It says 16 minus 8 divided by 2, what does that say? To the second power, and we do have a special word for that, squared. So we have 16 minus 8 divided by 2 squared plus 14. We're going to use order of operations to simplify this down. GEMS. So G. Grouping symbols. Do we have any grouping symbols that we have to work with? No. All right, so we move on. E. Exponents. Are there any exponents here? Yes. So we have to take care of that now. What's the exponent? 2 to the second power. We're going to take care of that. Everything else will stay exactly as is. And we're going to write the whole thing down. So I just start rewriting. 16 minus 8, division symbol, and then 2 squared turns into 4. 2 times itself is 4 plus 14. Now continue. Do we have any grouping symbols? No. Do we have any exponents? No. Do we have any multiplication or division? Yes, we do. And how does that go? From left to right. So I'm going to start over here. Okay, that's subtraction, so I'm leaving that alone. And then here's division. So I have to do that right now. 8 divided by 4 is what? 2. Technically, that's a negative 8 divided by 4, which is technically negative 2. So when I write that down, I have 16, and then that negative 2. So minus 2 plus 14. Everybody okay so far with this? Okay. Now, continue. No grouping symbols, no exponents. Do I have any more multiplication and division? Nope, so move on to the S in GEMS, which is subtraction and addition at the same time from left to right. So I start over here and I say 16 minus 2 is 14. So I write down 14 plus 14, which is 28. At this point, when you're down to the last step, go ahead and do it. 28. All right? I want to show you something off to the side. On this last step that we had right here, 16 minus 2, I'm just going to write it over here. 16 minus 2 plus 14. If I forgot that subtraction and addition have to happen at the same time from left to right, and I thought I should add first, what do I get here? 16 minus 16, which is, okay, do you see how we get that wrong answer? So you have to do the correct order of operations from left to right. You have to follow that. And it is so important that you actually follow the left to right. If subtraction happens to come first, then that subtraction happens first. Got to do it that way, otherwise you're going to get the wrong answer. This is where I see most mistakes happen in these types of problems. So be careful. The other place I see most mistakes happening is, let me back up one more. On this very first problem that we did here, people want to get through this problem so much that they'll end up adding before they multiply. And if you do that, you get what as an answer? 25, which is wrong, okay? You have to do the multiplication before the addition. So make sure you are following GEMS. Let me go back. Okay, let's talk our way through the second problem. What do we do? Yes, because in our minds we were thinking there are no grouping symbols, there are no exponents. We do have multiplication or division from left to right, and the multiplication in this case is 42 times 2, which is, so I'm going to write what? Minus 5. Okay, now what? Addition and subtraction from left to right. Now this time we do see the addition first, so we're going to go ahead and do that addition. This becomes 87 minus 5, and 87 minus 5 is probably right about 82. Circle your answer and you're done. Notice how I'm doing this, line by line by line. One thing at a time, eventually you get to your answer. Okay? We have one more thing here. Question, do I have any grouping symbols? Yes. Do you see it? It's the division bar. The division bar groups the top and the bottom. This is a grouping symbol. So we're going to have to take care of the top first. That's why it's a grouping symbol. It tells me to take care of one thing or the other first. So you want to take care of the top first. So we're on this group. Inside that group, do we have any new grouping symbols to talk about? No. So we move on to exponents. Do we have any exponents to talk about? Yes. So we're going to write down what? 2 times 2 times 2 is 8. So we have 8 minus 5 divided by 15 plus 9. Okay, so we're still in that top group because there's still more stuff to do. What do we get in that top group? 8 minus 5 is 3. Divided by 15 plus 9. Is there anything left to do in that top group? No. Go to the bottom group now. Is there anything left to do there? Yeah, we have 15 plus 9. What's 15 plus 9? 24. So I have 3 divided by 24. Is there anything left to do in that bottom group? No. Is there anything left to do on this problem? Yes. What do we have to do? We're dividing. 3 divided by 24. Is that a division problem we can do? 3 divided by 24. 24 divided by 3 is 8. 3 divided by 24 is a fraction. We can't do this division, but we can do what? We can reduce this to what? 1 over 8. Very good. And that's our answer. Did we have to do the division? No. But we did have to reduce it. We wound up with a fraction. We actually had a fraction the entire time. Did it seem like we had a fraction? Not at all. Because we're treating it as a grouping symbol. So don't be afraid of these fractions here. They're not that big a deal. It's easy for me to say, right? Yeah. All right, let's try to talk our way through this. I'm going to go around the room and ask you guys what we need to do. So, Daniela, what should we do first? The grouping symbol. Inside the grouping symbol we get 4. And I'm going to write okay, do I have any grouping symbols remaining here? I still see parentheses, right? Did I have to write parentheses here? No, I didn't. Instead of the parentheses, I could have put a dot. I'm using parentheses here now not as a grouping symbol, but as a show of multiplication. All right? Kind of like when we had the 0.2 in parentheses to the 5th power. That wasn't a grouping symbol either. It was just showing me that that was all one thing. This is just one thing right here being multiplied times 5. Okay, so what do we do next? I'll go with Katie. So in GEMS we are on the M. Multiplication and division from left to right. Good. So the first thing we see is, so we get 2. 4 divided by 2 is 2. And what do I write? Good. Plus 5 parentheses 4. Okay, we're getting there. What's next, Vanessa? So we're still on the M, right, in GEMS. We have the 5 times 4, which is, so I'm going to write 2 plus 20. And I know some of you were already saying 2 plus 20 is 22 in your head, but I want to see that 2 plus 20. Okay? Show me that step. And then finally our last 22. Okay, I'd like you to try this one. It is more complicated, but see if you can piece it together, and then we'll talk about it. So what comes first in order of operations? Grouping symbols. Do we have any grouping symbols here? Yes, we do. Okay, which grouping symbol comes first? So we have parentheses and we have brackets, right? Which one is grouping more stuff? Which one is grouping the other, actually? So these brackets right here, if I drew those really big, you could kind of see that these brackets are including all of this stuff, okay? So you have to recognize that. The outer grouping symbol is what we're talking about right now. Now we're going to go inside that grouping symbol. When we do that, we have to start all over again. So we start with, are there more grouping symbols within that group? And the answer is yes, right here. These parentheses right here are a grouping symbol within the group. So we have to do that first. All right? Now what happens inside the parentheses? 2 plus 3 is 5. Okay, so we're going to write that line down. As I was walking around the room, I saw a lot of people doing a little bit more in their head. And I understand that you can, but for right now, please write down every single step. Give me line by line. I know you're giving me dirty looks, but you really need to do it, because if you're making a mistake and you're just giving me like 1 or 2 lines and I don't see every step, I can't find your mistake for you. And right now is the time where we need to learn how to do this correctly. So I'm going to write this down. I have 6 bracket 32 minus, in parentheses, 5 squared bracket. Okay? Now we're still living within this grouping symbol. We took care of the grouping symbol within that group, right? We took care of this. So what comes next? The exponents. Now keep in mind, we're in this group right now, so I'm only looking at what's here. Exponents within this group, do we have any? Yeah, the 5 squared becomes 25. So I'm going to write the 6 on the outside, the bracket, the 32, and then minus the 5 squared, which is 25. Close the bracket. Within that grouping symbol, do I have any multiplication or division? No. Within that grouping symbol, do I have any addition or subtraction? Yes. So within the grouping symbol, I do the addition and subtraction. If there was other addition and subtraction going on somewhere else, it doesn't matter, because right now I'm only working in here. Everything else stays the same. 32 minus 25 is 7. So now I have 6, this bracket, 7. And what is that? It's 42. You have to be very systematic here, okay? Take your time, line by line, one thing at a time. This last one, let's talk through this one, since I only did one example like that before. Let's just talk our way through this. What do we see? There's a grouping symbol in the form of a fraction bar. So where do you want to start? The top? Okay. Morgan, on top, what do we have? Good. Within the top group, we have another group. So let's go within that group and start over. Within this group right here, is there another group? Is there an exponent? Within this group, is there an exponent? No. Is there multiplication or division? No. Is there addition or subtraction? Yes. So that's where we are. 4 plus 5 is 9. So we're going to write 9. I can leave it in parentheses if I want to. I don't have to. And then the 2 as an exponent means, so 2 is another, to the second power, I could say squared instead. Divided by 3 times 7 minus 4. All right, so that's the bottom group that we haven't touched yet. It stays the way it is. On top, do we have anything else that we have to do? Yeah, the exponent. 9 squared is 81. It's 9 times 9, not 9 times 2. Be very careful with those exponents. This is 81 divided by 3 times 7 minus 4. I know I'm kind of writing this screwy, but I really want you guys to write line by line by line, okay? Up here it's a little bit different because I don't have a whole lot of space. All right, is the top done? Yes. Go to the bottom. What do we have first? Grouping symbol. Inside the grouping symbol we have 7 minus 4 is 3. So we're going to write 81 divided by 3, parentheses 3. And now those parentheses mean times. So in the bottom we have 81 divided by 9. 81 divided by 9. Does that simplify? Yeah, what's 81 divided by 9? It's 9. So your answer is 9. Okay, again, it was a fraction. Was it complicated looking? Yeah, definitely. But you tackle it piece by piece, line by line, and eventually you wind up with a very simple number, 9. Okay, so just take your time on these. Homework 9 through 23 odd. You are capable of doing all of those problems at this point. I'll give you the rest of the period to do that.